well, we've gotten through your initial getting into solving inequalities. And the big idea here is that there are an infinite number of solutions, which is why we show it with a graph. You find that significant number, decide if your circle there on the graph is open, meaning we don't include the number, or fill it in, which means you do. And then which way do you shift or color in, shade it to the left or to the right? So we're going to do the same thing now, but we're going to have inequalities where we have to solve them by multiplying and dividing. And you're going to see something, that we have to make sure we watch out for. We haven't had to worry about this before because it didn't apply when we solved equations. All right. So find this spot in your notes where you have this big blank box for multiplying and dividing. And I want you to draw a squiggly line down the middle. All right. So let's start with a statement that we know for sure is going to be true. So let's do this. Something like 7. 7's supposed to be a lucky number. Okay. I know that 7 is less than 10. That's a foregone, totally, yep, that's a total fact. It's true. Now, if we decide to take 7 is less than 10, and we perform the same operation on each side, like before we were doing addition or subtraction, and it didn't matter what we did, the inequality always stayed true. So let's test this out with multiplying or dividing, okay? So let's just keep it easy, and let's say we decide to multiply both sides by 2. So I'm going to say 7 times 2 and 10 times 2. And I'm going to put a line down the middle, okay? All right, let's evaluate each of those. 14, 20. All right, is that still true? 14 is less than 20? Yep, certainly is. Cool. All right, let's take this inequality again, 7 less than 10. Switch back to purple. And this time let's try dividing by something. Let's divide by, let's divide by 2. Okay, so if I take 7 and divide it by 2, and if I take 10 and divide by 2, let's see what happens here. This gives me 3.5, or 3.5, 3 and 5/10. This gives me 5. Is this still true? Less than? Yeah. If I visualize that on a number line, sure, that's still true. So at first glance, it would look like this always happens to be true. Okay, let's just try one more in here. I'm going to squeeze in here. What if I had something like -4 and a +8? Now I know that -4 is smaller or less than +8. If I multiplied both of those by, let's say, even 3, pick a number like 3. If I went times 3 times 3, multiply by 3, multiply by 3, I'm doing the same thing to each side. I get -12, I get +24, still less than? Yes. So you'd think that, oh, well, then we just go about our business like we always do. Well, hold on. Okay. Let's come up with something else. I kind of like the -4 and +8 one. So let me grab that one again. Okay. So I'm going to jump over to this side of my dividing line. Okay. -4 is less than +8. I know that that's true. When I come over here and let's say I'm going to multiply, I'm going to take -4, and I'm going to take +8, and this time I'm going to multiply by -2. Multiply by -2. Watch what happens. On the left-hand side, -4 times -2 is a +8. And on the right-hand side, the 8 times -2, if you're remembering your rules with integers, I get -16. Is this still less than? No. No. This inequality symbol should go that way. Okay. Let's do the same inequality again over here. -4, +8, less than. What if I try dividing? And this time let me divide by -2. And I'm going to take this 8 and I'm going to divide it by -2. Now I'm doing the same thing to each side. If this were an equation, no problem. You just divide and you keep your equality symbol. But this, look what happens. -4 divided by -2 on the left-hand side of this inequality here is +2. Over here, 8 divided by -2 is -4. Is a +2 less than -4? No. No, no. So to make this a true statement, I really need to change my inequality symbol and flip it. So this becomes a very important thing, okay? I'm going to put a star here, and I'm going to say normal multiplying and dividing by a positive number, it's fine. But if you multiply or divide, and I'm going to abbreviate this with symbols now because it's our notes. If you multiply or divide by a negative, I'm going to write that super big. By a negative number. Here's what we have to watch out for. You must flip the inequality sign. Flip the sign. So if it was less than, you're going to have to go make it greater than. If it was greater than, make it less than. If it's less than or equal to, flip it to be greater than or equal to, and so on. All right? So let's start tackling some of these and see what you come up with. All right? All right, let's look at some of these examples. Solve and graph the solutions. So here I see my variable y. Y currently is being divided by 3. So to undo this, to use the inverse operation, we are going to multiply both sides by 3. Multiply by 3. Now, are you multiplying by a positive number or a negative number? It's positive. If it's positive, you're cool. Just proceed as normal. Okay? This would give me 3 times y divided by 3. This 3 is in the numerator. In the denominator, those divide out to give you a 1. 5 times 3 is 15. Do not flip it. We were multiplying by a positive. If we're working with positives, you're fine. All right, so here we go. I'm just going to throw 0 in here somewhere. I'll say 15 perhaps is up here. I want greater than or equal to. This is my significant digit right there. I'm going to fill in the circle. I want everything greater than. That's to the right, to the right. So I'm going to fill that in and make my arrow large and filled in. So it indicates to me every number 15 or larger satisfies that inequality. So 16, 15.5, 20, 100, all of those numbers are bigger than or equal to 15. All right, let's take a look at this next one. -4x is greater than 52. I need to get x by itself. So in order to undo that multiplying, -4 times x, we're going to undo it by dividing. All right, so we'll change color here. Now divide by -4. Divide this side by -4. Hold your horses. If we have to divide or multiply both sides by a negative, we must flip this one. Okay, so it's no longer going to be greater than. I have to flip greater than to be less than. A -4 divided by -4 is +1. And I get a 1x, or just x. Sweet. On the right-hand side, 52 divided by -4 is -13. All right, I flipped it. I've got it all simplified and everything. Now we just need to graph it. So let's say 0 is up here somewhere. -13 would be down here somewhere. Put your circle there. Because it is just a less than symbol, there's no equal sign under there as well. So leave your circle open. Less than means to the left. So you're going to shade this way, make a big arrowhead, and fill it in to indicate all of those numbers to infinity. Take a look at the next one. -10 times y is less than 60. Okay, let's do this one. Let's see, I wonder if I can make this a little bigger so I can see what in tarnation we are doing here. Wow. Okay, this one, I'm going to undo the multiply with divide. I have to divide by -10. Divide by -10. Dividing by a negative means I must flip it. Okay, so I know down here it's going to be greater than. -10 divided by -10 is +1. So I get a 1y. 60 divided by -10 is -6. There's your solution. That inequality y is greater than -6. My solutions are every single number in the universe that's bigger than -6. So I'm going to put a circle right here at -6. I'm going to leave it open because there's not an equal sign there. And I want everything greater. So that's to the right. So I'm going to shade it in this way. There's a whole lot of number line there. Make a big fat arrowhead. Sometimes it's really difficult to tell if we've shaded on top of a pre-printed line. So just go ahead and fill in the arrow, and then it's obvious. All right, this very last one here, and I've got to try and bump up my screen. Let's see if I can get that to zip up here. Gosh, that's a stubborn thing. Here we go. All right, this one. Now, I'm going to rewrite this first because 7 greater than or equal to. So you have t over 6 with the opposite sign, or that negative sign, out front. What I'm going to do to make this a little easier, when you have a negative sign in front of a fraction, you can either put it in the numerator, put it in the denominator, or leave it out front. I kind of, in this case, I'm going to put it down here with the denominator, okay? Cool. Let's solve for t. When you solve for t, you need to undo what's happening. So we need to undo that division by multiplying. So here we go. I'm going to multiply this side by -6. I have to multiply this side by -6. You have to ask yourself now, flip or not flip? Well, I'm multiplying, and I'm multiplying by a negative. So I'm going to flip. Definitely flip. When I do that, this then becomes less than or equal to. I have -42 and -6 in the denominator divides with the -6 in the numerator to give me +1, and I have t. Now, I've told you I hate having my variable on the right-hand side. To me, that is difficult to read because I always like my variable on the left. So I'm going to rewrite this guy this way. I'm going to put t on the left and -42 on the right. And this symbol here was pointing towards the -42. So I've got to write it this way. Sorry, apparently Walter's right here and he thinks he wants to play. Come here. Come here. Hey, come up and say hi. Say hi. Look in the camera. Say hello. We're doing some math tonight, aren't we? Yes, good boy. All right, hold on down. He wants me to play fetch. Little does he know we have to do algebra. All right, so here's your inequality. T is greater than or equal to negative 42. Put your circle at negative 42. This one has an equal sign, so I'm going to color it in. Zzz. It says greater than, which means to the right. So we're going to shade this way and fill in this arrow solid. Another reminder, if you're still getting confused, as long as you have the variable on the left side, then you can just look at which way the less than or greater than symbol is facing, and that is basically the arrowhead you color in or shade in, and that's the direction you go. Okay. Whew. All right, let's look at a few that might be written as a word problem instead. Oh, holy Hannah, where am I? Come on, let's go. All right. Every month, $35 is withdrawn from Tony's savings account to pay for his gym membership. Okay, I kind of have the same thing. He has enough savings to withdraw no more than $315. Okay, so let's figure this out here. How many months can he pay for his gym membership? Every month, $35 every month. So let's think about that. They're asking for how many months. That's going to be our variable. Let's pick a letter. M, perhaps? Okay, so I'm going to let months be represented by the letter M. Every month I have to pay, or Tony has to pay $35. Okay, so $35 times however many months. Okay, and it says he can't have any more than $315. Let's put $315 here. So if I can't go higher than that, I always have to stay under that amount. Makes sense. You only have this much in your account. You can only withdraw until you would get to zero, and then you're done. The bank's not going to let you go beyond that. So no more than, even though it says more than, it says no more than, not more than. That means less than. Could it be exactly equal to? Yeah, it could be exactly equal to. All righty, here's your inequality. To figure out how many months that is, we're going to undo this multiplying by dividing. Divide by 35. Divide by 35. 35 divided by 35 is 1. Hey, do I have to flip this one? I'm dividing by a positive number. If you're dividing by positive, let it be. Let it be. Let it be. All right. So I'm going to keep it as less than or equal to 315 divided by 35. Now, got to get your handy dandy calculator. I will say this. It's not going to be as big as 10. I'd need 350 divided by 35 to give me 10. So I'm guessing it's probably close to 9. Yeah, there it is. It's exactly 9. There you go. So he can pay for up to 9 months. Okay. Now notice I have my answer there, but what I would really like you to do is write this out in a sentence now. Didn't say to graph it, but he can pay for 9 months. That would be the maximum though, or less. You know, he could quit. Sorry, that's kind of messy. All right. So he could pay for 8 months. He could pay for 5 months. He could pay for 2 months. Maybe he just decides this gym isn't what he wants. I don't know. Whatever. Okay. Whatever. So let's practice a few in your packet. And basically the things there is just to get you to understand when you have to flip and when you don't have to flip. Okay. In the meantime, though, what I want you to do is look at Schoology and see what your assignment is. All right. And as always, good luck. and may the force be with you. Watch out when you have to flip and when you won't flip, okay?